ohms or 19 milliohms. That means if I want to run 10 amps through a cell with a threshold voltage of 2 volts, I need a total voltage of approximately 2.2 volts. At 2.2 volts, the reaction would be about 56% efficient conversion of electricity to hydrogen and oxygen. More voltage would increase the current draw of the cell and the production rate of gas, but it would also reduce the efficiency because out of the current that's going in, only 1.23 volts of it is going into electrolysis and the remainder is going into heat. There's also a maximum current density because as the production rate for a cell goes up, there's so many gas bubbles forming that they actually create non-conductive voids in the electrolyte and increase its resistance. This is why if you apply a relatively large voltage to a cell, you'll momentarily see a very high current, but over several seconds it will drop as more bubbles are produced until it settles into equilibrium. So rather than increasing the voltage on an individual cell, the energy efficient thing to do is to have multiple cells in series. So if you put 2 of these example cells in series at 4.4 volts, you're still pushing 10 amps, but the efficiency is the same and the gas output
my
is
bad,
doubled.
sorry.
On the flip side,
I was
4.4
burping.
volts across a single cell could theoretically give as much as 126 amps, but the efficiency would be just 28% and you would overheat extremely fast. If you just kept cranking up the voltage like this, all you'd have is a water boiler that
And you
spits out
saw.
hydrogen and oxygen as a byproduct. There's also the issue of logistics.
It
It's
doesn't
easy to find
lose
power
raining
supplies
or
that are
something.
40, 50, even 100 volts with 10 to 15 amps of output, but it's a lot harder to find power supplies that can put out several hundred amps at a few volts. The few supplies
Jesus.
that can do it are probably much more expensive per watt, too. So the most practical solution to a high-output HHO generator is to have as many cells as possible, but using a relatively moderate current, like 10 or 15 amps. In my case, the plan is to have 20 cells at 10 amps being fed by a 48-volt supply, meaning each cell would be at 2.4 volts.
I have a problem.
So the obvious solution is to have a big stack of plates separated by gaskets, which is exactly what a so-called
shit.
dry cell is. The problem is, every single time I've tried to build one of these, they eventually leak no matter how much effort I put into sealing them. So the alternative is to put the entire plate stack in the electrolyte as one piece, a so-called wet cell. But this is actually a terrible design, which is why I said at the beginning of the video that people are building HHO cells wrong. I was referring specifically to so-called wet cells. If all your cells are physically separate, the voltage of your power supply would be evenly divided between the cells, and they'd all be producing the same amount of gas. But when you just shove the whole plate stack in an electrolyte bath and turn on the power, that's not what happens. This is because the current has the option to simply bypass the inner cells rather than passing through them. If the resistive voltage across the section of electrolyte is less than a 2 to 2.5 volt drop across this cell, it's just going to bypass it altogether, so the only plates that are actually producing any gas are the very outer ones. Here's a small example with 6 cells that have a large amount of space on either side that current could flow through. At 11.4 volts, we've got a whole 10 amps, but look at the gas production. It's only on the outer plates, and none of the inner cells are producing anything. If I measure each cell individually, we can see the problem. On the outer cells, we've got a voltage drop of around 2.5 volts, but on the inner cells, they're all far below the threshold for electrolysis because the current is just going around them. As it currently stands, this stack is just generating mostly heat. Now let's see what happens if I put barriers between the cells. Now these barriers aren't sealed, so a little bit of current can bypass each cell, but it's a small enough amount that it's not a huge problem. When I apply a few volts, we can see at first there's a small amount of gas generation on the outer cells from that small amount of leakage current, but as I crank the voltage up, it evens out, and just by observing the bubbles, we can see that all 6 cells are producing approximately the same amount of gas. The difference in output is really clear if we compare the cell voltages to the previous configuration. At really low voltages, there's some imbalance due to the leakage current, but once we crank it up a little bit, it more or less evens out. If the cells were physically separated, this would pretty much be a perfectly flat line, assuming the geometry of each cell was identical, but this is close enough to work fine, I think. So here's my design. It's a case that holds 21 2x6 inch stainless steel plates for a total of 20 cells. The edges have 7 millimeters covered on either side to act as a sort of collar to minimize the bypass current without totally physically separating the cells. This reduces the available plate area, but at my goal of 10 amps, it should still be under 200 milliamps per square centimeter, which is a pretty reasonable current density. I start with these 2x12 inch plates and cut them in half by hand with a hacksaw, leaving the clean edges at the bottom of the casing and the messy edges sticking out the top slightly where it doesn't matter so much. The enclosure will be a casing for a water filter. There's a lot of unused space inside that'll be filled with extra electrolyte, but the reason I chose this is because I wanted to build up 5 to 10 psi of pressure to operate the torch, and the casing has 2 O-rings which will seal the whole thing under pressure. To connect the leads to the cells, I cut narrow slots in the casing cap, ran 1-inch strips of stainless through, and then sealed the gap with silicone caulk. Then I did a pressure test with compressed air, and we do have a little bit of gas escaping, so I guess I'll have to add some more sealant. The terminal lugs are just some 1/4-inch copper tubes crushed onto my wires because I'm too lazy to go and get proper crimp terminals. Once that's done, I fill up the casing with distilled water and add the sodium hydroxide electrolyte. I'm adding enough to make a 10% solution, which should provide more than enough conductivity to hit my 10 amp target at 48 volts. A printed standoff is added to the bottom of the casing, and the purpose of this is just to make sure the cell bottoms out at a known depth so I know where it'll end up with respect to the water line since I can't see inside the thing when it's closed up. Here's a graph of current versus voltage. If the cells were perfectly separated, we'd have zero current until we hit around 40 volts, which is about 2 volts per cell. But because of bypass current I mentioned earlier, we get a little bit of current before all the cells start electrolysis. And there's some gas production. So far, so good.
Schau mal, was ich mir gekauft habe.
Damn, wie hast du dir denn das alles leisten können?
Ach, ich zahle das einfach über 6 Monate online ab, easy.
Oh, du weißt schon, dass das deinen Schufa-Score verschlechtern kann, oder? Schufa-Score? Vielleicht habt ihr schon mal von der Schufa gehört. Das ist die Schutzgemeinschaft für allgemeine...
Here you can see the pressure inside the cell rising when I hold my thumb over the output tube. The bubbler is just a smaller, clear water filter casing that has a 3D printed adapter glued into the inlet port with a silicone tube that goes down to the bottom of the casing. This one also uses a 1/4-inch barb fitting sealed on to the larger PVC threaded plugs. To test the flow rate, I got an empty plastic bottle and measured its volume, 1.92 liters. The plastic bottle is completely filled with water and placed upside down in a much larger bucket, which is also filled with water. I flow gas from the output tube up into the plastic bottle and measure the time it takes to fill. I should point out that this is super dangerous because at the end of the test we'll have almost 2 liters of this explosive gas. Fragmentation risk isn't very high, but hearing damage is a real risk if this goes off, so I make sure to wear eye and ear protection here. I also ground myself and make sure there's no ignition sources nearby. Anyway, once we get bubbling outside of the bottle, that means it's completely filled with gas and the water has been completely displaced from it. At 43 volts and 4.4 amps, it took 2 minutes and 48 seconds to fill the bottle, and at 45.5 volts and 9.5 amps, it took 1 minute and 15 seconds to fill. Working out the chemical energy versus the input power and time, that comes out to 48.2% and 47.2% efficiency, respectively. This is actually pretty good because theoretical efficiency is 57% and 54% respectively, and we're not too far off from those numbers, so we're getting almost all the gas we possibly can given the input power. Just an interesting side note, when the bottle is completely full, you can see it's somewhat opaque, and this is just a mist of superfine sodium hydroxide particles. The sodium residue is the reason the torch flame will come out bright orange. If it's totally pure, the flame is actually invisible. Now for the torch. For the first iteration, I used an M6 threaded brass adapter because it can either fit a big welding tip or a nozzle, which come in various diameters below 1 millimeter, so I can thread in different ones to see which works best.
I have no goddamn time.
Inch copper tube, which came out really messy because I didn't have flux, but it did seal when I tested it under pressure. At around 10 amps using a 0.4 millimeter nozzle, we're getting just under 4 psi of pressure to the torch. The gas is moving fast enough to blow this sand out of the way. Seems like it's too fast to ignite a stable flame though. So I switched it to a 0.8 millimeter nozzle, and that seemed to work pretty well. Donald Trump is deporting trans people by launching them into the sun. Gavin Newsom is giving free mansions in Beverly Hills to MS-13. We have 2 weeks to act on climate change before the Cheesecake Factory is underwater. And this is your last chance to buy gold and trucker supplies before Russia presses the big button. If these headlines sound hyperbolic or biased, well, that's good. On either side of the political spectrum, the news is meant to sell you a narrative and usually dramatically exaggerates or misrepresents events to get clicks. This video's sponsor, Ground News, collects related articles from dozens of news outlets into one place and ranks them based on political leaning, factuality, and ownership to determine what sort of bias an article has so that you can think critically about the news you read. For example, if we click on the story of Trump talking about a tax hike, we can see how these different sites report on it and the different language they use and the spins they've put on the story. Here we can see this one is mostly being covered by right-leaning sources, but there's also a left-leaning source reporting on it, which could balance things out. They also have a blind spot feature which shows stories that are being over or underreported by either side. Ground News is completely subscriber funded. It doesn't have any ads, which helps keeps it independent, since, as you're probably aware, advertisers play a really big part in influencing what stories a news outlet does or doesn't run. Check them out using
Anyway,
the QR code
that
or
is
go to ground.news
the process
/hyperspace
with some Discord spam.
Advantage plan. Okay, back to the thing.
Yeah.
Here's what the flashback looks like when the system is powered off.
Oh,
The snap isn't really too loud as